Hey guys, so with the homework assignment that we have for tonight, I think there's only about 4 or 5 problems. They're a little bit more involved. Every single one of them deals with the Pythagorean theorem or the converse of the Pythagorean theorem. And so I just want to give you a better picture of kind of the depth of what you can do or how the Pythagorean can play into different problems. So I want to get right into it. What I've done is I've selected a couple of problems from 2 of them actually from your homework assignment. So you want to kind of copy down what I'm doing and fully understand what's going on. And then I've got another one that's not in the assignment but will help you with a different type of problem there. So hopefully you see and understand anything that's not fully stated in the video here. So anyways, let's get into it here, and I'm going to go over here to actually the page. Oh, and this is probably timed out on me. Oh, hey, it didn't. Sweet. All right, so we are down here, and it says here for 38 to 40, we are going to find the perimeter. If I can get over there. Find the perimeter and area of each figure. Now remember, the perimeter is the sum of all sides, right? Over here in number 39, that's really simple. You don't have to do any calculations other than the basic perimeter. To get the perimeter of number 38, you're going to have to figure out this third side. How are you going to do that? Well, you're going to use your Pythagorean theorem, figure out what that length is, and then add it to the other 2 lengths right here, okay? Now remember, if we're leaving it in simplest radical form, then if this is not a whole number, then you are going to need to figure out, then you want to keep the sum of these 2 separate of this one because it would be considered unlike terms, okay? Now, the area of a triangle is 1/2 base times height, and the base and height have to be perpendicular to each other. So as I look here, here's a right angle, so that means that this length and this length are perpendicular to each other. That means the base could be considered 12 and the height is 16, or vice versa. It really doesn't matter, okay? In number 39, I see a right angle right here, okay? So that means that this is our height right here, and this is our base. So you're going to have to figure out the length of the height. Well, I have a right triangle right here. How do you suppose we're going to figure out that height? Once you have the height, you can take 1/2 that length times the base, 1/2 base times height, and that will give you the overall area in number 39. Now, I'm actually going to work through number 40 with you, this trapezoid over here, which is a combination of 2 figures that we can figure out how to find the area of. And if I go back here, right there we go, okay. I'm going to, so you see the definition of perimeter, there's sum of all sides, and I think it's that one. There you go. Hopefully you can see that pretty well. Maybe I can even come down here a little bit. There you go, okay. So what we're going to do is we're going to figure out the area of this trapezoid. Now, I'm thinking that if I divide it, and I'm sure a lot of you were thinking the same way, if I draw that line in right there, I can find the area of this rectangle here and then add in the area of the triangle. Now, as I work my way across, the area of the rectangle is going to be very simple. I'm just going to go ahead and do the base times the height. So this is 4 times 8. Okay, that's the area of the rectangle. Now, the area of this triangle is going to be a little bit more complicated. I'm going to go ahead and put 8 right here as this length. And this length right here is not 8 as well, but if this length is 4, this picture is not drawn to scale, you're going to see that in a second. So from here to here is 4. That means from here to here it is 6 because the overall length is 10. 6 plus 4 is 10, okay? So to figure out the area of this over here, I'm going to do 1/2 the base, I'll say it's 6 for now, times the height. If you get those 2 switched, does it change the problem at all? No, okay? 1/2 8 times 6 is the same thing as 1/2 6 times 8. So if I work this out, I get 8 times 4, which is 32. Half of 6 is 3 times 8, which is 24. And so to finish this off, this is 56, and I'm going to put down square units, or unit squared, either way, okay? So that's the area of a trapezoid, of the trapezoid that we were given. Now, the perimeter, I have got to work out some calculations here. This length right here, I'm going to put down as C. If if you look at the right triangle that I currently have, I'm going to go ahead and say 6 squared plus 8 squared is equal to c squared. Okay? I'm going to figure out that length of the hypotenuse right there. If I work it out, 36 plus 64 is equal to 100. And in order to do a square, I square root. The square root of 100 is 10. So the length of C is going to be just 10 right there. Okay? Now, to get the overall perimeter, I'm going to go ahead and do this. I've got a length of 10 here, a length of 4 here, a length of 8 here, and a length of 10 here. And so in total, my perimeter, 24, 32, 32, and I'm going to put down units. It's not square units because it's not an area, just units. Could be length, feet, meters, we have no idea. Okay? So that is number 40, okay? Perimeter and area. Now, going back to the problem here, we were going to do 42. I picked number 42 as another one that is part of the problem that I was having you work through. It says here, the sides of a triangle have lengths 2x, 8, and 12. If the length of the longest side is 2x, what is the value of x that makes the triangle acute? Okay? What values of x make the triangle acute? Okay? So let's actually go back. I'm going to go back here. Sorry about that. And let's go right here. Okay. So I wrote down the equation that we talked about last week about the converse of the Pythagorean theorem. If c squared is less than a squared plus b squared, we have an acute triangle. Okay. Now those three lengths are, I got to write these down. The longest length was 2x. The next length was 8, and the next one was 12. Okay. So if we apply this here, if I work this out, we should be able to figure out what possibilities we could use for x that would form an acute triangle. So if we square 2x, that has now, and we're squaring both of these here, I get 4x squared, and I gotta go less than here, 64 plus 144. If I add those together, I get 208. Okay, so I'm gonna divide both sides here by 4 to get x squared by itself. That gives me 52. And then when I square root 52, I want to make sure I simplify my radical here. 4 times 13 is 52. So therefore my value of x is going to be 2 square root 13. When I square root 4, I get 2. Okay? So any value less than 2 square root 13 is going to give me an acute triangle. Okay? Now I just thought about something here. Obviously, if this is going to be a triangle, just realize this here. If this is going to be a triangle, okay, my value of x, I'm going to go down here, 2x plus 8 must be greater than 12, right? Because the sum of the two shorter sides, so if I go back to my original side lengths here, these two, the two shorter sides, must be greater than the longest, and I didn't do that right here. Let's see if I can work this out. The sum of the two shorter must be greater than the longest, okay, for it to be a triangle, okay? And so, let's see, there we go. Therefore, if I add those two together, 20 divided by 2, x has to be less than 10. That didn't really help me out at all, because I already know it had to be less than 2 radical 13. Now if I go back here, 2 second radical 13 gives me 7.2. So I already know if it's going to be acute, it's got to be less than 7.2. I guess the other thing I was thinking was this. This is a better idea. In order for this to be a triangle, remember this is our longest side right here, right? Okay, so you can ignore this part. I shouldn't have even done that part, okay? If this is going to be a triangle, this is going to be the longest leg of or longest side of the triangle, then it's got to be longer than, longer than 12. Greater than 12. There you go. Okay. Yeah, this is making more sense now. Okay. So from here, if it's the longest side, it's got to be greater than 12. If I divide through by 2, here we go, x has to be greater than 6. Okay. Now you remember a moment ago, it's got to be less than 7.2, right? The 2 radical 13. So what I'm going to do to get my range of possibilities for x on this, it's going to be bigger than 6, but less than 2 radical 13, okay? So I know at the very end there, I led you astray a little bit with this part right here because that didn't help us out. So again, I hope you can just delete that. But this is the key. If this is the longest side, it has to be larger than the second longest side. And so I went ahead and figured out what range that possibility could be, and x has to lie between those two. Okay? All right, now, to finish things off, I would like to look at number 46. So let me give you a preview of what, wrong one. Let's look at 46 here, what that one says. So number 46 says this, just find the value of x, okay? So this is a right triangle, and so I'm going to go ahead and do the Pythagorean theorem here to figure out what possible values of x you could have, okay? So as I work this out, okay, hopefully that makes sense. A squared plus b squared equals c squared. Now the reason why I wanted to show you this is because I wanted you to understand that when we square x minus 3, just to review that, for those of you not in Algebra 2, it's been a while since you've probably done this, or just to review it. So FOIL, first terms would be x squared. The outer terms would be negative 3x, and positive 9. Okay, so that's all x minus 3 squared. Now I'm going to square 9, which is 81, and that has to equal x squared. Okay. Now from here, I know you're seeing the x squareds and you're thinking, oh shoot, not those again. But you know what? If I go ahead and subtract x squared from both sides, they cancel each other out. So I can go ahead and do this. Negative 6x plus 90 is equal to 0. Okay. And I might even add the 6x to both sides, so we're dealing with only positive numbers. And then divide through by 6 to get x equal to 15. Okay. Now, you could always go back and double check your work just to make sure you've done it correctly by plugging it back into the original problem. So if I do that, 15 minus 3 is 12. And then you have x for 15, okay? If this is right, the question is, are they equal? Okay, if they are, then we know we've done our Pythagorean theorem correctly. So if I work this out, we have that. And what is 144 plus 81? It is 225. In fact, this is a 3 times 3. Remember, this side was 12. 4 times 3. And this is a 5 times 3 triangle. So it's a 3, 4, 5 right triangle, okay? So anyways, those are 3 problems from your textbook. You have some practice ones that are very similar. And so I want to see what you can do. So give your best effort, and we will talk tomorrow. Adios.